Example 1.28 is often repeated 10 mark question. Okay, so let's get started. So in this you have to use the rank method and find out for what values of mu. So there is a mu here, right? So for what values of mu this system of equations can have a trivial solution and a non-trivial solution. The difference between this and some of the previous sums that we have seen in example 1.24, for example, the difference is here this is a homogeneous equation. If you see, all your equations have are equated to 0. It's a homogeneous equation, right? So in that case, how do we find a trivial solution and non-trivial solution? As always, the first step is you write your set of equations in the matrix form, right? So let's write the coordinates of a, b and x, y and z. 1 1 3 4 3 mu and 2 1 2. This, when we multiply with x, y and z, we get the resultant matrix. It's a homogeneous equation, so we get 0 0 0. Okay, now we can write it in the form ax equal to b. Okay, now in the rank method, what is the first thing we will do? We will be writing the augmented matrix, right? What is an augmented matrix? It's nothing but writing both A and B matrix together. So 1 1 3 0, 4 3 mu 0, 2 1 2 0. Okay, so in the rank method we expect the first row first column element to be 1. Here it is 1 already. The next step is to make this fellow here a 0, right? If I have to make him a 0, what will I do? I will multiply row 1 by 4 and then subtract it from row 2, right? So I'll write the first row as it is. So this is the augmented matrix AB. Now this matrix becomes, we write the first row as it is. The second row now becomes R2 is equal to R2 minus 4 times R1. We are doing this to make this element here a 0. Okay, so 4 minus 4, 0. 3 minus 4, minus 1. Mu minus 12, right? So this will become mu minus 12 and this remains 0. Okay, then the third row will become, if I want to make this element 0, I will say R3 is equal to R3 minus 2 times R1. Then only this will become 0. So 2 minus 2, 0. 1 minus 2, minus 1. 2 minus 6, right? So it becomes minus 4. And the last one remains 0. Now, the next thing is, we have to bring it to the echelon form. That's what we are trying to do. We have to make this element 0. If I have to make this element 0, I will subtract it from R2, right? I obviously can't subtract it from R1. Then this element here will become a minus 1 again, right? Add it with R1. So for that, what I do is, I say, I'll write R1 as it is, because I'm not going to do any more changes. I'll write R2 also as it is, 0 minus 1, mu minus 12 and 0. And R3, what I'm going to do with R3 is, I'm going to say R3 is equal to R3 minus R2, right? So it becomes 0 minus 0, 0, minus 1, minus of minus 1, so it becomes minus 1 plus 1, 0, and minus 4 minus mu plus 12, right? So it becomes 8. I'll just write down here what it becomes, minus 4 minus of mu minus 12. So this becomes minus 4 minus mu plus 12, right? So it becomes 8 plus 12 and minus 4 is 8 plus 8, 8 minus mu. So that's what we are writing here. 8 minus nu, the last term becomes 0. So I think apart from this we can't do anything further. So we have two terms here, 8 minus nu and nu minus 12, right? If I have to bring it to the echelon form, right, I can have two cases here where mu is equal to 8 and the other thing is mu is not equal to 8. So first let's see the case where mu is not equal to 8. When mu becomes not equal to 8, obviously this will not become 0, right? This last row will not be 0. And also let's assume that mu is not equal to 0. What if mu is equal to 8? Then this term could become 0, right? So let us make an assumption that 8 minus nu is also not equal to 0, right? Then you will have the rank of the matrix as 3. Okay? The rank of the matrix of A and B will become equal to 3. And what will be the rank of A? The A matrix alone. That will also be equal to 3. Okay? Your rank of AB matrix, the augmented matrix, will be equal to the rank of A, which is equal to 3, which also happens to be equal to the number of unknowns, right? What is number of unknowns? What are the unknowns? They are x, y and z. So whenever the rank of the matrix is equal to the number of unknowns, right, then we say that the system is consistent, right? Which implies the system is consistent and it will have a trivial solution. What is a trivial solution here? Because this is a homogeneous equation, you can straight away write the trivial solution as x equal to 0, y equal to 0 and z equal to 0. Because your resultant matrix is only a 0, 0. It's a homogeneous equation, right? So you can say that the system has a trivial solution with x0, y0, z0. This is, you can straight away write this. Okay? This is the rule when you have for homogeneous equations, when the rank of the matrix, augmented matrix, is equal to the rank of A matrix and the rank is also equal to the number of unknowns, right? In this case it's 3. You can straight away go and say the system has a trivial solution and the values of x, y and z being 0, 0, 0. Okay, and it has a trivial solution. This you have to mention. Okay, so this is case 1 when mu was not equal to 0 and we assume that 8 minus nu was also not equal to 0. Now let's see case 2, right? In case 2, let us assume mu is equal to 0. What happens when mu is equal to 0? Your augmented matrix will look like this, right? Let me write it down. It will be 1, 1, 3, 0, 0, minus 1, mu minus 12. So I am assuming mu is 0, so it's minus 12, 0 and 0, 0. I'm assuming mu is equal to 8 here. Okay, so 8 minus 12 will give me, you're right, minus 4 here, and 0, 0, 8 minus mu, since mu is 8, this becomes 0, 0. So in this case, I'll have a rank of A comma B, right, will be equal to 2, right, because I have only 2 non-zero rows, which is also equal to rank of A, right, because if I take the A matrix alone, I will have again only 2 non-zero rows. Therefore, the system is said to be consistent. But this 2 here is lesser than the number of unknowns, right? The number of unknowns being 3. Therefore, we can say that since the rank of AB is equal to rank of A, the system is consistent, right? But it can have infinite solutions. In case of homogeneous equations, we say the system will have non-trivial solutions, right? So how do we find that? So let me repeat it again. Since the rank of a comma b is equal to rank of a, which is q, right, you can see the system is consistent because their rank is equal. But because it is lesser to the number of unknowns being x, y, z, you will say that the system is consistent. However, it has infinitely many non-trivial solutions, and this non-trivial solution can also include the trivial solution x is equal to 0, y is equal to z is equal to 0. So suppose we said it has infinitely many solutions, right? So as always we have to find at least one solution. So how do we find it? Let's write the equations from the echelon form matrix, right? So it will be x plus y plus 3z equal to 0 minus y minus 4z equal to 0. So I can write this as y plus 4z equal to 0, or I can say y is equal to minus 4z. Okay, now let's substitute this in the first equation. In this equation, so x minus 4z plus 3z equal to 0, which implies x minus z equal to 0, therefore x is equal to z. Now let's make the assumption that z is equal to k. I am making this assumption because I have only two equations to find out three unknowns, right? So we'll assume one of the unknowns to be a constant k. So then this equation becomes, right? And one thing is, you should know that k is a real number, right? But which is not 0. Because if k becomes 0, your x, y, z will again become 0, 0, 0, which is again a trivial solution. It includes a trivial solution, you're right, but we want to find a value for x, y, and z which is also not a trivial solution. So let us assume k is equal to 1, right? In that case, your x will become 1, y will become minus 4, and of course z is equal to k, so we will get z is equal to 1. So this is one of the solutions when we assume k is equal to 1. Likewise, you can have infinite solutions. So with this you can stop the sum, because you have proved for which cases it's trivial and which cases you're having non-trivial solutions, and for a non-trivial infinite solution you have also found out one of the possible solutions. So this sum you can easily find with the rank method, but more important is how you give the proof, right? So you should say that, for example, in case 1 you can say the rank of A augmented matrix is equal to rank of A, and it is also equal to the number of unknowns, therefore the system will have a trivial solution. And for homogeneous equations, the trivial solution will be x is 0, y is 0, z is 0. And in the second case you can say that, the reasoning that you write here, right, is very, very important. That carries the weightage. So this is a very important 10-mark sum, and we will be doing some sums similar to this from the exercise also. That will be the next sums that we will be doing.